So here, the step one system, or I choose two systems. M and a small m. Step two. So let's call this system one. System two. Step two, FPD. For this guy, don't forget, find minimum m. That means this gets so light that this starts to move this way, right? So the friction force here is this way. Let's show you. The friction force against the direction of moment, Fs, this way. And if you go this way, the friction force here is Fs, this way. There's two different friction force, right? All right, so now I put this thing around it, find body force, surface. For body force here, for surface force, I have the friction force, Fs, normal force, then tension, and then come back here, nothing, all I have is gravity, F dot m g. And since this is theta, then this angle is also, this angle is theta. Now go to system 2. System 2, the friction is this way. Normal force this way. And go all around it. There is a tension. Alright? And gravitational force, which is small mg. And this angle is beta. Right? So that's my FPD. Now equation. For this system, now I choose this XY. I choose the X here, Y here, and here I choose X here, Y here. You remember we said you can rotate this axis like the way you did in CAD software. You can put it in different points. It's all up to you, right? So summation of force here in X is equal to big mg sine theta minus fs minus t equal to 0. And also moment, don't forget, this is not at the center. This is just shifted a little bit with x. The moment equation is just drive the distance x, the geometric center. You just use to find the geometric center because that's not the point. We have some that is sliding, right? So I don't do that. I don't use the moment. So that's all I get. In the x, you have mg sine theta. This way positive. And then negative Fs, negative T, 0. In the y direction, mg cosine theta, negative, plus n is equal to 0. So that this is for system 1. For system 2, you get this guy. You get T minus mg sine theta minus Fs is equal to 0, and in fact, this guy, don't forget, this is n in system 1. You see, n in system 1, they are not necessarily equal in n in system 2. These are two different things, Fs system 1, Fs system 2, right? They are not same thing. When we say Fs, that doesn't mean that they are same because there are different masses, different amount of friction. So Fs1, N1, Fs3, N2. I forgot to do that. So here you get Fs1, N1, and here you get Fs2. So T minus Fs2 minus mg sine beta is equal to 0. And then in the y direction, you get N2, right, minus mg cosine beta, mg cosine beta is equal to 0, right? And one more thing, this equation, in order to close the system. Look, how many unknowns do I have? 1, 2, right, 3, 4, 5, 1, 2, 3, 4, 5, right? How many equations do I have? 3. For this system, 3 for, sorry, m. Also, this 2 is also unknown. This 2m, right? So if you add all together, you get that you get more than 6 equations. And I only have 6 equations from this two system. So I have to have more extra equations to close the system. We call it closure, right? So the extra equation is just come from here. So in this system, I have one extra equation that will say Fs1 is mu S1 N1. For this part, the friction is equal to the coefficient of friction, which is equal to mu S, both of them. Both of them same wood, same material, so the same mu S. And then Fs2 is mu S N2. Now this system is closed. Now I can solve it. How do you solve it? Well, here, let's solve this for t. So t becomes mg, take it to the right side, mg sine beta plus Fs2. Fs2 is mu S N2, and N2 is mg cosine beta. So if somebody asks you for tension in the cable, that's the answer, if that was the question. But the question is, say, find the relation for M in the minimum case. Minimum case, that means the case that is about to slide down. That means the friction is this way. If it was asking for maximum, then it would slide the other way. So the friction, all you do is just flip the sign of friction. But the value becomes, the formula becomes different, right? So you have a t here. Now let's solve here, t. So you get t is equal to Fsm g sine theta minus Fs1, which is mu S times N1, and N1 is mg cosine theta, right? Now, since t is same, right, put t here. You see the tension in cable is same, it's one cable, right? This t is the same. In fact, if you write the moment equation that in the center of pulley, you get this t is equal to this t, right? Because the pulley is frictionless. If the pulley was not frictionless, we cannot say that. So I say, well, this should be equal to that. And that would give me a relation between a small m and capital M. So t, which is mg, let's write it here. mg, factor out m times factor out mg. mg times sine beta plus cosine plus mu s cosine beta. This is t, should be equal to this one, right? Which is m factor g again times sine theta minus mu s cosine theta, right? G cancel out the g, then you get a relation for m. So m is capital M times sine theta minus mu s cosine theta sine beta plus mu s cosine theta. That's the relation. That's the relation we get. Now when you go home, solve, find the maximum. This is the minimum t. You see, you have a negative here. It gives a small t. So what is the question? What is the maximum possible for n? If you add weight here, this is going to split the other way. When you go home, solve that, find the maximum as a homework. It's optional. You don't need to tell me.